Yes, so let us start lecture 12 on computer networks. So in the previous lecture, we were discussing about subnetting. Okay, and I have given you clear picture what exactly is subnetting and all. So now we are going to extend few questions. So in IP addressing, basic thing is we have to solve lot and lot of question. Okay, if you are able to solve the questions, then your topic is over. So let us take an example. I'm saying that we have a class B block. Okay, class B block is given and its starting address is 136.45.0.0, and this is distributed among four different organizations. Okay, it has been distributed among four different organizations. So now I want to find first and last address of first and last address of says third organization. What you will do? Third organization. So it is very easy how to do this thing. So now see, in the previous lecture we have done sequentially. That means first organization, first and last address, second organization, third, fourth, and so on. So now they can ask from in between also, first and last address of third organization. So for that, what we will do, we will say since four organizations, so we will borrow 2 bits from here. Okay, from the third octet. See, first 2 octets are reserved for class B, na? That is for net ID. From host ID, we will borrow 2 bits. Okay, why 2 bits? Because four organizations. So 2 power 2 is 4. So 2 bits we will borrow. And for first organization, these 2 bits will be 00 for the first organization. For second organization, it will be 01. For third, it will be 10, and for fourth, it will be 11. Now try to imagine in your head what we are going to do. So for third organization, I'm saying first and last address. So what it will be 136.45.10, and after that we have 6 zeros. So 128.0. Okay, until what point we will go? See, we 10. First 2 bits are fixed. So total 6 bits. 6 bits can go from 61. 61 is 63. So 128 plus 63, it comes out to be 191. So we will go till 136.45.191.255. Please let me know if you have any doubt.
Understood, sir.
Okay, yes, that's good. So this type of question can be asked. Let me do another question. Take the snapshot. I will jump to the next slide.
Done, sir.
Okay. So let us suppose I say class A block. Okay, I think this logo is creating. This is very big logo. So let me. I think there is some problem. Let me clear that out. Uh, yes. Yeah. Now I think it's perfect, na?
Yes, sir.
So now we are doing a question. So we are saying that we have a class A block. Okay, class A block. Rather, they will not say that also. They will simply say a block having starting address 76.0.0.0 is shared among 8 organizations. 8 organization. Find first and last address of, say, they will say sixth organization. Okay, so what we will say, sixth organization. So since 8 organizations we have shared, and first of all we will see the class. This is class A. From the range we can guess that it is class A. So now from the next octet, that means this octet, we will borrow how many bits? 3 bits we will borrow, because we have to share them among
Among
8 organizations.
yes,
Okay,
sir.
so three bits we will borrow, and we want sixth organization. So for first organization it will be 000 and so on. So for sixth it will be, for one it is 0. For second it will be 001. So one less. So for sixth it will be 101. That's it. So game over. So now we will say 676.101. These are fixed. Starting address will be what? All 5 zeros. After 101, all 5 zeros. So what is 101? So 128, 64, 32. So 128 plus 32. So it comes out to be 160. So 76.160.0.0 to 76 dot. See, this is 160, and then we will have 1, 2, 3, 4, 5. 5 ones. 5 1 means what? 31. So you add 31, it will become 191. So 76.191.255.255. Any doubt?
No, sir.
Okay, so take the snapshot. I will jump to the next slide, and we will
Done.
do just one more question. Done. Okay.
Okay.
Yeah. So let us take say 200.30.40.0 shared among 16 organizations. 16 organizations, and they are
It's
saying
class C.
first. Yeah. Please come again.
It's class C, sir.
Yes. Good. Good. It's class C. Class C. Yes. So first and last of say I will say whatever we want. Say 12th organization. Okay. So what we will say 12th means one less. Now we have done na one less. So 1011. 4-bit we will have to borrow because 16 organizations. So 2 power 4 is 16. So 4-bit we will borrow from which octet? From which octet? This last octet,
Last
because
one.
3 octet will be fixed only. So we will say like this 200.30.40 dot. Now this we have to figure it out. So of 4 zeros will be there. So what is this 1011? This is 128, 32 and 16. So you add them
176, sir.
128, 176. Okay, so 200.30.40.176 it will be starting address, and till what point we will go? All 4 means 15, so we have to add 15. So 200.30.40.15 65 181. Okay, please check this out. Any doubt?
Last won't be 255, sir?
No, 12th organization na?
Yeah. It is not last we are talking about. It is.
Yeah, so see this. Actually 16 organizations, so 4-bit we have borrowed. 4-bit we have borrowed. So now last 4 bits are left out. So you will take 4 zeros to 4 1.
Sir.
Okay, so 4 1 means 15. So simply add 15 to 176. You will get the answer.
Yes, sir.
Any doubt?
No, sir.
Okay, so take the snapshot. I will jump, and same scenario was here itself. But by chance, these all were becoming 255 because we are not touching them. We are not touching this octet also. We
Yes,
are
sir.
touching
Yes, sir.
this
Yes,
octet
sir.
only, and only
Understood.
2 bits were borrowed. Okay, yes, sorry, 8 organizations and 3 bits will be borrowed. That's it.
Yes,
Okay,
sir.
so I think you have got the point. So take the
Hmm.
snapshot. I will jump to the next slide. So now
Done.
from in between also we can do. So first type of question was sequentially, first and last of each and every organization sequentially, and now we have done randomly also. Okay, from any organization, anything we can do now. So I hope we are comfortable with all these things. So now
Yes, sir.
let's dig deep into this subnetting topic. Take the snapshot. I will jump to the next slide.
Perfect, sir.
Okay, so now question arises how routing will be done in subnetting. Now question is how routing is done in subnetting. Okay, so to answer this question, we have to first remember the fact that this subnetting is our internal, you can say, matter. Okay, it is not publicly available. For example, you are doing carpooling, so it is your internal matter. It is not visible to it is not visible to public. Okay, so if anybody is seeing your car, just by seeing your car, he or she cannot guess that you are doing carpooling. Okay, you are doing it just for the cost cutting purpose. So entire public do not know about you are doing carpooling or not. It's your private choice. Same is the case here. Subnetting is your private choice. Nobody knows about it. That means internet router have no knowledge about subnetting. It's your private decision that I'm not able to afford this much big block, so I am sharing with some other organization just for cost cutting and so on. So first of all, first point which you should remember is, let me use another color. Internet router has no knowledge about subnetting. Internet router has no knowledge about subnetting. Okay, so rest of the public do not know that you are doing carpooling and all. It's your choice, it's your personal decision, that's why you have done it. So same is the case here. Internet router has no knowledge about subnetting. So now how routing will be done? So indirectly what I want to say is, see, if I am saying that class A block is say class A block 73.0.0.0 is distributed among 4 organizations. Roughly I'm writing 4 organizations. So each and every internet router will have only one entry, that is this only. This internet router will not do these four different entries. Are you getting it? So if we are
Yes.
doing these four different entries, then what is the use? So our aim is to decrease the number of entries in routing table. But if router know this subnetting and all, then their number of entries will increase. We do not want to increase. We want to decrease the entries. So that's why internet router has no knowledge about subnetting. It's your private choice. So internet router will have only this entry. Okay. So that means now let me show you the diagram. Take the snapshot. I will jump to the next slide.
Done, sir.
Okay, so now for example I am having this this is a router. Okay, and now we have done subnetting. So we have a class A block 73.0.0.0. Okay, so roughly this address is given to this entire network. So now here we have four different routers, okay, which will forward the packet to the respective host. So this router is connected with a network whose since we have divided it into four different subnets now. So
Yes.
four subnets. So so starting and last address will be what? 73. Okay, I think there is a space issue. Okay, so let me write it like this: 73.0.0.0 to 73 dot uh, 0
128.
dot 255. Okay, we should say 63 now. 73.63.255.255. Please let me know any doubt here. First organization. So divided by, into two. This we have divided into four organization. So from here we will buy 2 bits. So 2 bit will be first time 00. So 00 means all zeros, and then here 63.255.255.255. Any doubt here?
63, sir.
63.255.255. Okay. So for next organization, from where it will start? 73.64.0.0 to 73.127.255.255. Okay. For
Yes,
third
sir.
organization, it will start from 73.128.0.0. Try to imagine in your head what we are doing. Okay, so 63, we have to add 63. So what it will become? 73 dot 191 dot 255, and the last one will be 73.192.0.0 to 73.255.255.255. Okay, yes, so these are the four different organizations. Okay, so if I say net ID of first organization, this is the net ID of first organization.
Yes.
This is the net ID of second organization, net ID of third organization, and net ID of fourth organization. So who will keep track of this? I have told you, na, router store net ID. It is not storing IP addresses. It is storing net ID. So who will store these for net IDs? This router. This is known as site router. This site router will store these net IDs. So that means 73.0.0.0. Next is 73.64.0.0. Next is 73.128.0.0. Are you getting it now? Now we are digging deep into
Yes,
the
yes, sir.
subnetting topic. 192.0.0. So these four entries will be done by this router. This is known as site router. Okay, so it's this site router responsibility to forward the packet. Okay, so now this site router has done these four entries. Okay, so and it will label them: port number 1, port number 2, port number 3, port number 4. So it will say port number 1, 2, 3, and 4. So now see this, here we have some internet router. Okay, and it has received a packet whose IP address is 73.45.60.70. I have told you this this internet router has no knowledge about this subnetting, so it will have only one entry, that is this. So it will have only one entry, so 73.0.0.0, and let us suppose it has to forward the packet from port number 1 so that it can come here. So it will have entry port 1. Okay, and how these entries are made, don't worry about them. We will tell you about this in routing algorithm. Next topic will be routing algorithm. In that we will study these how these entries are made and so on. So for now you just imagine that we have some entries here. So this internet router, let me label it. This is internet router. Okay, so internet router. Internet router has only one entry, 73.0.0.0 and port number 1. That's it. So now it has received this IP address packet. So what it will do, I have told you many times that it will do, it will apply net mask. First of all, it will find the class. Class is A. So it will say okay. Net mask is 255.0.0.0. So it will apply it. It will say 73.45.60.70, and now it will say since it is class A, so it will apply 255.0.0.0. So finally it will become 73.0.0.0. Okay, so now it will search the table for this entry 73.0.0.0, and luckily it find the entry and it will say from port number 1 I will forward the packet. That's it. Game over. So this is for internet router, and there might be many internet routers and all these will be having only this entry. Okay, so now finally the packet having this address will reach the site router. Now question arises, what site router will apply? If it apply this net mask, then obviously it will say 73.0.0.0. It will forward the packet to where? From port number 1, and by chance this IP address belong to this range only. This is by chance. Okay, so let me change it. Let me change it so that we get more clarity. So let us suppose I take it say 73.200.60.70. So finally we will get 70.0.0.0. So here also I will change it 200. Okay, so now we will obviously get a wrong answer. Okay, so this packet arrives at this internet router. Same story. This packet arrives at internet router. Internet router will say, okay, let me. I do not know anything. I will simply say class A. Class A net mask is available with me. I will apply it, and I will find 73.0.0.0. It will forward the packet from port number 1, and each and every internet router will do the same thing. And finally, it will be received by site router. Now, what site router should do? If site router also say the same story, that means class A, apply the net mask, and then forward. Obviously, what it will do, same result, na 73.0.0.0. It will forward from port number 1, but since this 200 actually belong to which block? This. Here it is there. Okay, so we are not able to forward here. So what this site router will do? So now site router will never apply net mask. It will apply subnet mask. Okay, so what is this subnet mask? Let me tell you that thing. So in case of subnetting, site router apply subnet mask. So what subnet mask it will choose? So I have told you 4 organizations. So 2 bits you have borrowed. So these 2 bit will be 1 now. So it will say I will apply 255.192.0.0. 192 means first 2 are 1. 2 bits you have borrowed, na? That's why 192. And now now you apply this subnet mask with this. You end with this. So what you will get? 73.200.60.70. So here no problem 0. Here no problem 0. Here you might face problem, but I will say 192. First 2 ones are there, and in 200 also first 2 ones are there. And rest other bits will be 1, but I really don't care. First 2 bits will be 1, that is for sure. So here I will get 192. Are you able to imagine it?
Yes, sir.
Okay, that's good. So now here 73. So what we will get 73.192.0.0, and this is this only. So we will forward the packet from this site router will forward the packet to port number 4, and finally this organization will receive it. So the story was, the crux was this subnet mask. So site router will not apply net mask, it will apply subnet mask to get the corresponding net ID of the organization to which packet will be forwarded. So this is known as subnet mask. Okay, so just to revise, internet router have no knowledge about subnetting. It's your internal wish, you have done it just for cost cutting, like carpooling. It's your wish, you are doing it, nobody knows about it. So internet router will simply forward the packet here. Okay, we'll have only one entry, that is this. Okay, so if they keep the entry, then they have to keep 4 entries. So what's the use of that 4 entries? We want to decrease the number of entries, but why we are increasing it? So our aim is to decrease it. So that's why they will have only 1 entry. So now they will forward the packet to the site router. Finally, this it's the responsibility of site router to properly forward the packet to the respective organization, and for that it will use subnet mask. So site router is not applying net mask; it is applying subnet mask. Okay, so you can take the snapshot of this, and then we will try to write few lines so that we get more clarity. Yes, you can take the snapshot. Okay, so please take some notes. You please write down. Internet router have no knowledge about subnetting. Internet router have no knowledge about subnetting. That is if class A IP address is distributed among 4 organizations. That is, if class A IP address is shared among 4 organizations, then still internet router will have only 1 entry. Then still internet routers will have only 1 entry corresponding to that class A block. Like this, only 1 entry. Okay, only 1 entry. Then still internet router will have only 1 entry corresponding to that class A block. Okay, so now what is the need? So hence we need a site router. Which will properly forward the packet to respective organization. Hence we need a site router. Which will properly forward the packet to respective organization. After receiving packet from internet.
Respective organization.
After packet to respective organization after receiving packet from internet.
Yes, sir.
Okay, so next point, site router will apply subnet mask. In place of net mask. Okay, yes. So I can simply say like this. So generally in net mask, what we are having in net ID, host ID. So net ID part is all ones. In net mask, what we are doing, net ID part all ones and host ID are all 0. That is the basic meaning of net mask. Net ID all 1 and host ID all 0. That is the basic scenario of net mask. So for subnet mask, what we are doing is we are borrowing some bits of host ID part. Okay, and this entire part will now become subnet ID and host ID. So subnet ID will be all ones and host ID will be all zeros. So for example, here 4 organizations were there. So you have borrowed 2 bits from the host ID part. Okay, so now you have increased the length of net ID and you have decreased the length of host ID. Okay, so you have borrowed few bits. Any doubt?
Can this all ones and all zeros could be altered in subnet ID?
No.
Right.
In this is subnet mask, na? Subnet mask.
Yeah. Subnet mask का जो subnet ID है sir. In that we still will have all ones and all zeros only.
Yes. So see this 255.192. So what we have done 255. See for class
All
A.
ones.
So for class A. Yeah. Please speak.
Whereas in the like when we are borrowing it, so there all zeros we can alter that statement.
No. When we have borrowed the bits, we will put all ones only. If we put all zeros, then obviously answer will be always 0. So what is the use of that?
In host ID then?
No, in host ID we have put all zeros.
It looks like the net mask now, sir.
No, sorry. No, no. Just a second. हाँ, ऐसा नहीं है, ऐसा नहीं है. See, in this was subnet mask ना. This
Yes,
was
sir.
subnet mask. So for net mask of class A was 255.0.0.0.
Hmm.
But now what is the subnet mask? We have 2 bits, and these 2 bits were 1. So why 2 bits we have taken? Because there were 4 organizations. So 2 bits we have borrowed from the host ID part, and these 2 bits we have to put 1. Okay, only then it will become subnet mask.
Yeah, sir. That we need not to show it here in the host ID. We have still mentioned all zeros and all ones.
So
All
host
ones
ID
show
part is now
here.
small, na. Host ID
Hmm.
part is now small.
Hmm.
Okay, it is not now. See, in class A, see this na. See the diagram, corresponding diagram you see.
Okay, okay, sir.
So till here we were having host ID. Now host ID has been shifted.
Hmm.
Are you getting it?
Yes, sir. Yes, sir. Yes, sir.
Ah. Okay, and the reason being why we are putting all ones, so that we get exactly what we are wanting. If we put all zeros here, so it's no use. It will become 255.0.0. That is nothing but class A, net mask only.
Uh-huh.
Okay. Yes. So now I think you have got the point. So till what point we have written?
That is, site router will apply subnet masking in place of net mask.
But that's it. So site router will apply subnet mask. So now many times question have been asked in gate, like class A IP address has been distributed among 4 different organizations. What will be the subnet mask? Immediately you will say 255.192.0.0. Is it okay?
Yes, sir.
So now we will try to practice this question on with subnet also. Okay. So they will directly ask what will be the subnet mask and so on. Okay. So let me show you those questions. So question number 1. So they will say class A IP address. Okay, class A block. Okay. So they will say class A block is shared among 4 organizations. 4 organizations. What is subnet mask? They will directly ask this question. Directly ask. So you will say class A. First of all, try to imagine class A net mask. 255.0.0.0. 4 organizations. So borrow here 2 bits. First 2 bits you will borrow, not last 2 bits. First 2 bits you will borrow. So first 2 bits means you will change it to 192. So 255.192.0.0. This will be your subnet mask. And who will apply this subnet mask? Site router will apply it. Okay. And why we are doing all these things? Just because internet has no knowledge about your subnetting. It's your choice whatever you have done. If internet router have knowledge about this subnetting, then it's entire loss. Why? Because in place of having 1 entry, these routers will have to do 4 entries. So that is big loss. That's why we have done all these things like that only. Let me take the snapshot. Let me show you other questions. Take the snapshot.
Done, sir. Done, sir.
Okay. So question number 2. Okay. So question number 2. So class A. Okay. And let me write it shortly. 8 organizations. 8 organizations. Subnet mask. So you will say 255.8 organization means 3 bits you will borrow. The first 3 bits will be 1. So what it will be? 128.60.192. Then plus 32 you have to do 32. So it will be 224. Okay, 224.0.0. Okay.
Sir, yes.
So next question, let us say class A distributed among say 32 organizations. So what will be the net mask? Sorry, subnet mask. Subnet mask we are calculating. Subnet mask. So 255.32 means first 5 bits will be 1. So now you can do the reverse order also. Like you have to add 16 also, 8 also. So it's better first 5 bits. Now so you will say like this: 1, 2, 3, 4, 5, and 1, 2, 3. Now if all these were ones, you will be having 255. Now these zeros means 7. Its value is 7. So 255 minus 7. You just subtract it and get the answer. So minus 7. What you will get? 8. 248 is my answer. 248.0.0. Any doubt?
No, no, sir.
Okay, good. Take the snapshot. I will jump to the next slide.
Done, sir.
Okay. So now they can ask question number 4. Class B, it is distributed among say 8 organizations. So what is the subnet mask? Very easy. Class B na. So you will write like this: 255.255. Now 3 bits you will borrow. So what you will get? I think we have done here na. What we were getting 224. So I will simply
224.
write 224.0. That's it. Done.
Yes, sir.
So now I think these questions are trivial, है ना? So let me do just one more for your just for the sake of completion. Class C distributed among say 16 organizations. Okay, subnet mask. Subnet mask. So what I will say, class C 255.255.255. This
4
is
bits,
net
sir.
mask. Now 4 bits we will borrow. 4 bit means what will be
254
our
plus
answer?
16.
So yeah, you can do like this: 255 minus 15, 240.
Yes, sir.
240. Okay. Yeah. So that's it. So this type of question are over. Now they can ask reverse question also. Let me show you that. Take the snapshot.
Done, sir.
Okay. So they will say net mask is having net mask has 11 ones. Okay. Uh, how many organizations have shared? How many organizations have shared dash class block? Ah, so 11 ones. 11 one means 3 bits you have borrowed. So yes, definitely good answer. How many organizations? So your answer is 8. 8
8.
organizations. Okay, which class? A. Class A block. Because 8 one means class A, na? And after that we are doing 3.
Answer.
Okay. So now another tricky question. Now if I will say netmask has 17 ones, how many organizations have shared a dash class block?
C class, sir.
17. See, 8 one means 255.
256. D, B, 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 sir.
हाँ B ठीक है. Okay. And how many organization?
Only one digit was reserved, sir. No.
हाँ 1 bit. So 1 bit means 2 power 1, that is 2 organizations.
Okay, sir.
Power na, we are doing power na. So 3 ones, so 2 power 3,
Yes,
that
sir.
was
Yes,
8.
sir. Yes, sir. Yes, sir.
But actually this answer is partially correct and partially wrong also. Actually this question is ambiguous. Gate will never ask this question. Why? Because net mask contains 17 ones, so probability is that it might be of class A. Okay, class A block, and class A block has 8 ones only, so 11 ones you have borrowed, so 2 power 11, that means 2048 organizations are shared. That is also possible. So I can say like this: class A block is distributed among 2 power 11, that is 2048 organizations. Are you getting it?
Yes, sir.
Okay, so the 2 answers are possible. If it is of class B, then only 2 organizations. If it is of class A, then 2 power 11 organizations have shared it. I think I have done a calculation mistake.
Hmm?
9, 2 power 9. 5 and 12. 9 plus 8 is 17, na?
Yes, sir.
Hmm.
Yes,
So
sir.
net mask has 17 ones. So how many organizations have shared? So if it is of class B, then only 2 organizations. If it is of class A, then 5 and 2 organizations. Okay, so 2 answers are possible for this question.
Yes, sir.
Is it okay? So similarly, now we can shift to other questions also, but basic idea we have got from here itself. Okay, but here there was only one possibility, that is class A. Okay, because for class B we should have at least 16 ones.
Hmm.
Okay, yeah.
Yes.
So okay, and we should write here subnet mask. No? Subnet mask has 11 ones. I have written here wrongly. Subnet mask has 17 ones. Net mask has 11 ones. It is not possible. Net mask will have only either 8 ones or 16 ones or 24 ones. Okay, and let me see the previous. Yeah, we have done correctly. Take the snapshot. I will jump to the next slide and I will write few more points.
Done, sir.
Okay, so now summary is that net mask, the knowledge which we are having till now, net mask can have either 8 ones or 16 ones or 24 ones. If we have 8 ones, class A, 16 ones, class B, 24 ones, class C. Okay.
Yes, sir. Hmm.
And they will say subnet mask. Another question I am telling you, subnet mask has 15 ones. Subnet mask has 15 ones. Find total number of subnets. So they will try to twist the question. Total number of subnets and size of each subnet. Okay, now they cannot ask starting address and last address. For that they have to give the IP address. How you will find first and last address? You cannot find it. I have not given you any address. I'm just giving you subnet mask. So what I'm saying is subnet mask has 15 ones. Find total number of subnets and size of each subnet. This is the question. So 15 ones. So we should first see 8 ones, 16 ones, 24 ones. So 8 ones. So 8 one, these has been extended now. So how many bits you have borrowed? 7 bits you have borrowed.
Yes, sir.
So 2 power 7, that is 128. So total number of subnets will be 128. So how we have calculated 128? 2 power 7, because 7 bits we have borrowed. Okay, and what they're saying is size of each subnet. Size of each subnet means number of IP addresses in that subnet. Please try to remember this. Size of each subnet means number of IP addresses in each subnet. So how many IP addresses? How you will calculate? Any idea?
So if it is 128,
Hmm.
that will be 128.0.0. It will be class 1, class A. So in that case,
No,
like,
I'm just saying. Size. We have to find the size, na? Number of IP addresses. Okay, so let me tell you that. Let me simplify the things. See this. In class A, if we have a class A block, total number of IP addresses in that block will be what? 2 power 24.
yes, sir.
How we have done it? In the previous lecture also we have done it. Class A, first block is net ID, last 3 blocks are host ID. Last 3
Yes, sir.
blocks means 2 power 24. The total IP addresses in each class A block is 2 power 24. Now what I have said,
Understood.
it has been shared among 128 organizations. Na? So 128 means you divide by 2 power 7. So size of each organization will be what? Size of each organization will be 2 power 24 minus 7. You will get, I think so, 17. Na?
17, sir.
17. So 2 power 17 is the size of each organization.
Yes, understood, sir.
Okay. So another way of doing can be, another way very simple. See, if you want to go by formula, but I will not suggest to do by formula. You try to do it by common sense. So total organization was 120K, that is 2 power 7. So 2 power 24 was the total IP addresses divided by 2 power 7. You will get 2 power 17. If you go by formula, what will be our answer? See, total IP addresses is 2 power 32. Okay, and then from that we have 15 ones you have then taken. So 15 bits is net ID now. Rather we should have subnet ID 15 ones. So 32 minus 15, again you will get 2 power 17 as the answer. Okay, so we can think like this: 32 bit total IP address is 32 bits. So first 15 bits you have reserved for net ID, or you can say subnet ID. Subnet ID. So how many bits are left out? 17 bits are left out. So the 17 bit will be for host ID. So how many hosts? How many IP addresses? 2 power 17.
Yes, sir.
How many IP addresses? 2 power 17. How many hosts? 2 power 17 minus 2 in each organization.
Sir.
Okay. So now let me jump to the next slide. Take the snapshot.
Done, sir.
Okay. Yeah, and one more point I want to cover here. That point is related to DBA, direct broadcast address, and net ID. So they can ask like this also. Question is, they will say class A block divided into 4 subnets. Okay, so they will say find subnet ID of second organization, and they will say find DBA of third organization. Okay, so like this they can ask. So let me tell you that also. So class A block, say, let me give you the IP address. So IP address is say 73.0.0.0 is divided into 4 subnets. So find subnet ID of second organization, find DB of third organization. So subnet ID of second organization. Subnet ID means, I think just like net ID, we have subnet ID. So first address. So they just want to ask you first address of second organization. So how you will find it? So we will say we have borrowed 2 bits. Second organization means 01. 01 means you will say 73.64.0.0. Any problem here?
No, sir.
Okay, yes, good. So we have find subnet ID of second organization, DB of third organization. So third organization will start from which IP address? 000110. Are you getting it now? 000110. 10 means 128. So now they want DBA, direct broadcast address. That means last address of third organization. So what will be the last address of third organization? Please tell me.
73.192.255.255.
192.
We'll say 191, sir.
Yeah, very good. 191.255.255. Yes.
Yes, sir.
Okay, so this is the DB of third organization. Okay, yeah, and one more question is coming to my mind. If they say DBA of fourth organization, what you will say?
DB of fourth organization.
So it will be very simple. Last organization, last organization means double one.
Yes, sir.
So it will be 73.255.255.255.
Sir.
Okay, now very beautiful point is coming. Please try to focus here. If we have a class A block, if you have not done subnetting, what you will say? Direct broadcast address for this class A block will be this only, na?
Yes.
Okay, and now if we have done subnetting, then it will be direct broadcast address for the fourth organization.
Yes, sir.
So they are same. Are you getting it? They are same. Okay, so now question arises, since internet router have no knowledge about subnetting, if they want that a packet should be broadcasted to all the you can say computers in this class A block, then how they will do it? Are you getting it?
Yes, sir.
So that is the biggest problem. So see the solution. Solution is that they will follow this IP address only. So if they follow this IP address, that means if destination IP address is this, then each and every computer in this you can say block will receive this packet, because internet router have no knowledge about subnetting. Okay, so now if some computer in this subnet want to do broadcast address DBA for this last organization, then they will use this IP address. So it's all the scope or where we are standing. For example, see this. This is your site router, and these are the four organization: first, second, third, and fourth. So this is your first organization, this is your second, this is your third, and this is your fourth organization. Roughly I'm drawing it just to give you the idea, basic idea. Okay, let me draw it like this. So this is your first organization, this is your second, this is your third, and this is your fourth organization. So now if I say you are standing here in the internet, so how you will see? You will not see these four, you will see only one organization, that is this big organization. So if you apply this destination IP address, packet will be forwarded to each and every computer in this network, because you do not know about this subnetting and all. But if you are standing here, like in this organization you are standing, or you are standing in this organization, and you want to do DBA, or you can say in this subnet, if you want to forward the packet or broadcast the packet in this subnet, you will use the same IP address. So it's all about where exactly you are standing. If you are outside the network, then you cannot do DBA somewhere. Okay, you will say I will do DBA in entire network. Okay, but if you are standing here, then you will say if I will use this, then I will do DBA here. Are you getting it?
Yes, sir.
So that's it. Okay, yes, so you can take the snapshot. I will jump to the next slide.
Copied, sir.
Okay, so now I think you have got the idea how we will find the net mask and all the subnet mask. These are very important points. Okay, directly direct questions also, reverse question also, like class B 8 subnet mask this, class C 16 organization subnet mask this. Okay, so you just borrow the bits and put them one. That is the basic idea. Okay, and if they have given you reverse question like 11 ones, then how many organization and so on, we have done this also. Okay, so basically our most important part is now over. Okay, now just for the sake of information I am telling you, because sometimes you might get confused. In older question that was the confusion, but here now we have no confusion. Let me tell you that also. RFC is a request for comments. Okay, so whenever we have some protocol or something like that in networking, we have RFC related to it. Okay, so RFC is, you can say, description of the protocol. Description of the protocol. Okay, whatever protocol you are studying in networking, that detailed description is given in RFC. So and you can say your entire computer network subject is documented in RFCs only. Okay, so if you want deep knowledge of any protocol, you will refer the RFC. You just simply type in Google RFC for say stop and wait. They will give you RFC for Ethernet. They will give you like that. So whatever protocol we have studied, for each and every protocol we have some fixed RFC, that is request for comment. Let me write it. Request for comments. So how these you might wonder that how these textbooks have been written. These computer network textbooks have been written from these RFCs only. Request for comment. So if you want, you can Google that out and you can read them also. Very easy language. It is not like that they are very tough. They are very easy to understand. Okay, very simple language they have given you. Of course, some words might be technical. You might not be able to follow them, but for the just for the sake of reference, I'm telling you, we can refer that also. Okay, so each RFC has some number. So if we take RFC 1812, this is the advanced version. So it is saying that if I am saying say 6-bit subnet number, that means 6-bit you have borrowed. So total number of subnets will be 2 power 6. Okay, directly. But we have older RFC 950. It was saying if you have 6-bit subnet number, then number of subnets will be 2 power 6 minus 2, just like host. Okay, so here wastage was very high in RFC 950. That's why RFC 1812 have been developed. So in older question of gate, this was followed. So you will say total subnets are 2 per 6 minus 2. But in new gate questions, this is followed. So we have to follow this only. So I am just telling you for your reference that you might get some old gate question, and in that they have followed this notation, so that you might not get confused. Just for the sake of information, I am telling you. That's it.
Yes.
Okay. Yeah. So you can take the snapshot. I will jump to the next slide.
Done, sir.
Okay. So now they can ask this question also. A block having IP address. A block having IP address 236.40.0 is shared among two organizations. Is shared among two organizations. Now they are asking question. First question, first and last IP address of each subnet. First and last IP of each subnet. Subnet mask. Net ID of each subnet. And D option, DBA of each subnet. Okay. So very simple question. We have done many questions like that. Just for the sake of practice, I have given you. So we can directly solve it. Okay. There is no big deal here. So see this. This is class C, na? Shared among
Yes,
two
sir.
organizations. Two organization means only one bit will be borrowed from here. So first and last IP address of each subnet. So if we find this, then directly and indirectly we have answered this also and this also. So let me say you that for first organization we will be having 200.36.40.0 to 200.36.40.1 bit we have borrowed. So last 7 bit 127. For second organization 200.36.40.128, because now here we will have 1. Okay, 1 bit we have borrowed, 1 means 128 to 200.36.40.255. Okay, net ID of each subnet, net ID of first subnet, net ID of second subnet, DB of each subnet, DB of first subnet, DBA of second subnet. Subnet mask will be class C, na? So first of all, write for class C 255.255.255. Now two organization, that means 1 bit we have borrowed, so it will be 128. Any doubt?
No, sir.
Okay, and they can ask number of ones in net mask. In place of asking this, they can ask number of ones in subnet mask. It will be 25, 24, 125. Okay, and they can ask number of ones in net mask. Net mask, obviously 24 ones. Any doubt here?
No, sir.
Take the snapshot. I will jump to the next slide.
Yes, sir.
Okay, so we have done subnetting, and why we have done subnetting? For cost cutting. If you are not able to buy a block, so you will share them between other organization. Now we are doing another topic, that is supernetting. We have done subnetting. Now we are going to do supernetting. Okay, what is this supernetting? Let me tell you that thing. It is just reverse of subnetting. As the name suggests, it is simply reverse of subnetting. So see this. For example, I say if organization need 1000 IP addresses, what you will do? 1000 IP addresses is needed by an organization. Okay, so this is the demand. How you will fulfill it? Class A, not at all. Because if you do class A, you will get 2 power 24 IP addresses, 16 million. Why you are giving 16 million? 16 million means 1.6 crore IP addresses you will give. You need just 1000. If you give class B, 2 power 16 IP addresses you will give. Class B block, if you give 2 power 16, 2 power 16 is 64, approximately 64k. 64k IP addresses. You want just 1000. Why you are giving 64,000? Class C, you will give 2 power 8, that is 256. 256 you will give, but you want 1000. So you cannot give class A, class B, class C. Nothing you can give. What is the best idea? Best idea is you give 4 blocks of class C to this organization. So directly, indirectly, how many IP addresses you will give? 4 blocks. So 4 into 256, that will be 1024. Okay, you can check it out. 2 power 2 into 2 power 8, that is 2 power 10. 2 power 10 is 1024. No doubt wastage will be of 24 IP addresses, and we have to do it. No way out. Okay, but this is the least wastage which we can expect. So if you want 1000 IP addresses, then you should give 4 blocks of class C. That is the best way. So earlier what we were doing, one block was divided into multiple subnets, but now you are giving multiple blocks to one organization. That means you are doing supernetting. Supernet you are making. Okay, you are not making network, you are making a super network. Why super network word is used? Because now you are going to combine 4 networks of class C. Okay, so it's just the opposite procedure. Okay, so you can take the notes. Please write first point. It is exactly opposite of subnetting. It is
Yes, sir.
exactly opposite of subnetting. Next point, if organization need 1000 IP addresses, if organization need 1000 IP addresses, then we can assign 4 blocks of class C. If organization need 1000 IP addresses, then we can assign 4 blocks of class C. Next point. So now I'm going to tell you the definition. Definition is we are assigning multiple blocks to one organization. That is supernetting. So write it. Process of assigning multiple blocks to one organization is supernetting. Process of assigning multiple blocks to one organization is supernetting. Okay. And what was subnetting? Exactly opposite. Process of assigning one block to multiple organizations. Please write it. Process of assigning one block to multiple organization is subnetting. Process of assigning one block to multiple organization is subnetting.
Yes, sir.
Okay. So now we will do why we will dig deep into it. Take the snapshot. I will jump to the next slide.
Done, sir.
Okay. So now, for example, see, this was the basic scenario. Net ID and host ID. Net ID and host ID. Okay. So, IP address was divided into 2 parts. Now we have done subnetting. So what we have done in subnetting, let me copy that also so that we get exactly same thing. Yeah. So now I will say what we have done in subnetting. So we have shifted this line towards right. That means we have borrowed some host ID bits here and we have put here all ones. Okay.
Yes, sir.
Now in supernetting, what we are doing, so I will say here subnet ID, subnet ID. Subnet ID. So in supernetting, what we are doing is, let me take it here. So in supernetting, what we are doing is we are going to increase this host ID part now. See, in subnetting, we have decreased this host ID part because we want less number of hosts, na? But now we want more number of hosts. So we will increase this host ID part. Okay. So we will increase this host ID part. So this host ID part we have borrowed, and here we have put all ones. So here we will put all zeros. And now it will become supernet ID. Don't worry, I will explain all the points. Take the snapshot first.
Done, sir.
Okay, so this was the basic scenario. In subnetting, we have borrowed the bits from host ID part. In supernetting, we will borrow bits from the net ID part. Okay, so in subnetting, borrow bits from host ID, from host ID. In supernetting, borrow bits from net ID. Okay, and here what we are doing, and put 1, and here we are saying and put zeros. Okay, yes. So now let me tell you some more things about it. Okay, so now see, uh, okay, so now first let me tell you the conditions for supernetting. Take the snapshot, I will jump to the next slide.
Done, sir.
Okay, so these conditions have been asked me directly. Conditions for supernetting. It is not like that supernetting is always possible. No, it is not like that. Okay, so let me give you those conditions. Okay, so first condition is that the number of blocks given to organization must be power of 2. Number of blocks given to organization must be power of 2. Okay, and all must be of equal sizes. Are you getting it? So indirectly what I want to say is number of blocks given to organization must be power of 2. That means any organization can demand, I say if my need is more, I will say please give me 2 blocks of class C, or please give me 4 blocks of class C, or please give me 8 blocks of class C. I cannot demand 6 blocks of class C. I cannot demand 3 blocks of class C, and so on. Or I cannot demand 3 blocks of class B, like this. So always it should be in power of 2. Okay, and all must be of equal sizes. That means I cannot say please give me 1 block of class B and 1 block of class C. No, give me 1 block of class B and 1 block of class C. No, it is not allowed. Are you getting it? So first point is saying must be a power of 2. So directly indirectly this means organization can demand, let me put it like this, organization can demand, these directly have been asking it, that's why I'm spending time here. Organization can demand 2, 4, 8, 16 dot 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 blocks of any class. Okay, but it can't say give me 3 blocks, 6 blocks, 7 blocks, 9 blocks, 10 blocks dot dot dot. It cannot say like this. Okay, but it can't say these. Second important point is organization should demand either all the blocks should be of class B, all the blocks of class A, or all the blocks of class C. We cannot mingle them up. Like organization can't ask the second point, all must be of equal sizes. What does this mean? Or let me write it, it can't say. Okay, why to write this organization again and again? Okay, it cannot ask uh, 1 block of class B and 1 block of class A. It cannot demand like this. Okay, or and 1 block of class B or class C, like this. Okay, it cannot say like this. This is not allowed. Okay, I hope you have got the point. So these two are the basic points. Okay, rather this was the first condition. Second, these blocks must be in contiguous fashion. So you cannot say give 1 block from here, 1 block from there, and so on. These blocks must be in contiguous fashion. I will tell you about it, don't worry. These blocks must be in contiguous fashion. Okay, so for example, if an organization need two blocks of class C, so you cannot say 200.40.50.0. First block is this, and second block is 200.40.60.0. No, this is not allowed. So with 50, you want 51 only. That means the next block 200.40.51.0. Yes, these two can be given, but these two cannot be given because they are not in contiguous fashion. It's just like that. You have buy one house and now you want more space, so you will buy your neighbor house also. Okay, so you cannot say if I want more space, you take another house which is two streets away from your house. Then what is the use of that space? Okay, so you should need continuous. That is the basic meaning. So these blocks must be in continuous fashion. Okay, or contiguous fashion. It cannot be like this, one in 50, one in 60. No, one is 50, another 51, like this, continuous fashion. That is the second condition. And the third condition is that the first block must be divisible by total number of IP addresses needed. First address, rather I should say like this, first address must be divisible by total number of IP addresses demanded. Let me explain you why we want these things. Okay, so first of all, take the snapshot. Then in the next slide, I will tell you the reasons of all these things. First reason is for sure. Okay, so no block given to organization must be power of 2. Number of blocks must be in power of 2, and all must be of equal sizes. These blocks must be in continuous fashion, and first must be divisible by a total number of IP addresses demanded. Take the snapshot. I will jump to the next slide.
Done, sir.
Okay. So for example, take example of class C. Okay, so you want two block of class C. Two block of class C. Okay, so what you will do? So for example, I say 200.40.10.0, and next block is 200.40.11.0. These two can be given. Okay, why these two can be given? Let me tell you the reason also. You want two block of class C, that means number of IP addresses demanded by you should be 512, na? That's why you are wanting two block of class C. Any problem here? Because one block of class C is having 256 IP addresses and you want 512 IP addresses. Any problem here?
No, sir.
Okay, so now see this address. So forget about 200, forget about 40. You just concentrate on these two blocks. 10. 10 is what? 4 times 0 and 1010. And here 0 means 8 zeros. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so here I'm placing dot, here I'm placing dot just to save the time, because I have to read, I have to write 32 bits. 32-bit writing is next to impossible. It will waste our time. So now just concentrate on these two blocks. So now see here, continuously there are 9 zeros here. So these 8 zeros have come from the last block, and because of this 10 we have 1 0 extra. So that's why total 9 zeros are there. So now comfortably I will say, na, 9 zeros to 9 ones you can revolve them and you will get 512 IP addresses. Okay, that's why first address should be divisible by total number of IP addresses. Okay, and
Yes.
router will also create problem in routing. I'm not digging deep into unnecessary details because it is not required for GET. Okay, the thing which is required for GET, only that thing I'm telling you. So you can just remember this thing, that we want continuous, from continuous zeros to continuous ones, we want this thing only. Okay, so that's why we are saying that first address should be divisible by total number of IP addresses demanded. Let's say this. So roughly they will ask you that why this is so that routing being impossible. Otherwise routing is impossible here. Okay, to possible routing, that's why we have done it. Okay, so to make routing possible, we have done this thing. Okay, and roughly you can imagine like this, that we have from 9 zeros to 9 1 we can do. That's why directly we will be able to do the things. Okay, so you have to remember these three conditions. These are very, very important, and these three conditions have been asked in GET directly or indirectly many times. Okay, Yes. So I hope you do not have any.
Yes, sir.
Okay. And one more thing I want to clear here. Take the snapshot.
Done, sir.
Okay. So this also done.
Yes, sir.
Okay. So one more thing I want to tell. Okay. I think slides are over. Okay. So one more thing is, so in case of subnetting, I have told you internet router have no knowledge about subnetting, but internet router have knowledge about supernetting. Internet router have knowledge about supernetting. Can you tell me why? Because if they have knowledge, then they will have to do only one entry. Otherwise, they will do 4 different entry for class C blocks. Are you getting it? If
Yes, sir.
4 class C blocks have been given to one organization, then they should do only one entry corresponding to it. They should not do different four entries. Okay, and
Yes,
our aim is to decrease the entries. That's why I'm saying that internet router have knowledge about supernetting.
done, sir.
Okay,
Understood.
yeah, and now because they have knowledge about supernetting, so now these internet router should apply what? Supernet mask. Okay, are you getting it? In
Hmm.
subnetting, what I was saying, internet router will apply net mask only. Okay, let me write it. In subnetting, internet router apply net mask, but site router apply subnet mask. Okay, but in case of supernetting, internet router will directly apply supernet mask. They will directly apply supernet mask. Now question arises how you will calculate the supernet mask. So for that I have already told you, you have borrowed the bits, those many bits will become 0. I have told you, see this, I have made a very beautiful diagram here. This was
Yes,
for supernet masks only. So this was for subnet mask, and this is for supernet mask. Okay, yeah. So now we can calculate. Okay, you can take the snapshot of this.
done, sir.
So now we can directly answer this type of question. So for example, they can ask, say, 4 class C blocks are given to an organization. 4 class C blocks are given to an organization. They will say directly. They will say, find supernet mask. Find supernet mask. So how you will see? So first of all, you will write net mask of class C 255.255.255.0. So now 4 class C blocks are given. So 4 class C blocks means, so see this, from here you will buy 2 bits. From where? From the last. You cannot demand from the first, because from the last then only you will get continuous 10 zeros to 10 ones. So from the last, see the diagram. If you have doubt, see this diagram. So from here I have borrowed the bits and we have put them zeros. So you just put them zeros. So if you will buy 2 bits and you make them zeros, so directly and directly you will subtract 3 from this. So what you will get? 255.255.252.0. Any problem here?
No, no, sir.
Net mask class C. So this is your supernet mask. Take the snapshot. I will jump to the next slide.
Done, sir.
Okay, so next question might be, say, 8 organizations share class C block, supernet mask. So class C 255.255. Okay, 8 organize. Sorry, I have done mistake here. 8 blocks of class C is given to one organization. We are doing super netting, na?
Yes, sir.
8 blocks of C given to an organization, and they are saying find super net mask. So net mask will be 255.255.255.0. 8 organization means 3 bit you will borrow. So you will subtract 7. So after subtracting 7, what you will get? 248.0.
Yes, sir.
That's it. So this is the net mask, and this is your super net mask. Take the snapshot.
Done, sir.
Now just for sake of completion, 16 blocks of class B to an organization, super net mask. 16 blocks. So net mask of class B, first of all you write like this. Okay, so this is for class B net mask. Now what they are demanding? 16 blocks. 16 blocks means 4 bits you will borrow. 4 bit means you will subtract 15 from here. So what you will get? 255.240.0.0. So it will be super net mask. So now I think these questions are trivial. You can do it yourself. Any doubt here that why we are subtracting 15 and all? 15 zeros, 4 bit last zeros. So you will get 250. Okay, that's it. So that's it. So this is all about supernet mask. So now let me give you a small idea. Okay, so that you get more clarity about why this divisibility condition was there. Let me jump to the next slide. So now for example, I will say an organization needs say 4 blocks. Okay, 4 block of class C. 4 block of class C. So I am giving these blocks. Is it okay or not? 200.40.36.0. Second, third, and fourth. These 4 blocks. So here I am saying 36, 37, 38, 39. Are these 4 blocks can be given to an organization? So step by step I will say first number of blocks must be power of 2 and they are of same sizes. So class C blocks are of same size, obviously we know, and 4 blocks, that means 2 power 2. Okay, so condition number 1 is fulfilled here. Are you getting it? See this if you have doubt.
Sir. No, sir.
So next is next condition was these blocks must be in contiguous fashion. So see this, are they in continuous fashion or not? 36, 37, 30, 39. Yes, they are in contiguous fashion. Third, first block must be divisible by total number of IP addresses demanded. Total number of IP addresses demanded is what? 4 block of class C means 4 into 256, that means 1024. 1024 IP addresses they are demanding. 1024 means last 10 zeros you want. We're getting it? Last 10 zeros. See this. I have to see this. First address must be divisible by total number of IP addresses demanded. Na? So total number of IP addresses demanded are what? 1024. So first address must be divisible. First address is this only. This is the first address of the block. So this must be divisible by 1024. How you will check this is divisible by 1024? I will say last 10 zeros. Why last 10 zeros? Let me tell you that also. If any binary number is containing last bit 0, it is multiple of 2. If it is containing last 2 zeros, it is multiple of 4. That means divisible by 4. You can take any number. This is 12. 12 is divisible by 4 because last two are 0. Any doubt here? So
No, no,
if I
no.
want if I want 102 for divisible, last 10 bits should be 0. So here you can
Oh,
check it out. 36 is 100 100, and here these 0 means 8 zeros will be there continuously. 8 plus 2 10, 10 zeros are there, and we want this only. So third condition is also fulfilled. So these 4 blocks can be given to an organization. Any
yes,
doubt
sir.
here? Huh.
No.
So now see this. So I have told you na internet router have knowledge about the supernetting part kind of thing. If they have
Mm.
knowledge about supernetting kind of thing, so what they will store? They will store only one entry, that means the first address of the block, that means this only. So each and every internet router will have only one entry, that is 200.40.36.0. They will have only this entry. No other entry will be there in their routing table. So if they receive any IP address in this entire block, okay, they want to find this number from that. For example, a site internet router have received an IP address, say IP received by internet router is 200.40 dot say 38.36. Internet router has received this. Okay, and now how it will find this number? That means I told you it will end with super net mask. Now there is nothing net mask here. They will apply super net mask. I have told you. See this. Internet router will apply super net mask. Internet router will directly apply super net
Super nice.
mask. I have told you. So super net mask will be what? Four organization of class C. So what will be that? 255.255 dot here 252.0. Any doubt here?
Because yes, sir, understood.
Because 2 bit you have borrowed from here,
Uh-huh.
from the second block. So for class C, it should be 255.255.0. But this 255, 2 bits you have borrowed. So subtract 3, you will get 252. Is it okay? So
Yes,
now
sir.
you end it. Because with netmask also we end, so here also we will end it. Okay, sorry for that. We will end with this na. Mm-hmm. Oh, in place of wasting time here, let me write it again. It will be much better idea. Yeah, so IP address is this, so it will bitwise end it with 255.255.252.0. So what you will get? 200.40 dot, see here, now try to imagine here 252 and here 38. So it will become 36.0. And you see this 100 100. This is 36, 38 means this only. Okay, and
Mm.
here we have 252. 252 means 1 2 3 4 5 6 7 and 8. 252 means 1 2 3 4 5 6, and these two are 0. Are you getting it?
Hmm.
So what you will get? And you just doing and 0 0 1 0 0 1 double 0. That is nothing but 36 only. So that's why I have written here 36. I have done this in my head only by imagination. I think you have done yourself also. 252 means last two are 0. In 38, last two are 1 0. So when we are ending it, and it will become double 0 only. See here we have got double 0. Are you getting it? Here double 0 and here 1 0. So you are getting
Yes.
double 0. Okay, so finally we have
Mm.
got 36, and this is what we were expecting. And finally, for example, router will say to forward the packet from port number 2, so it will forward the packet from port number 2, and game over. Any doubt here?
No, sir.
Okay, so now imagine if first address is not divisible by total number of IP addresses. For example, if I want to give these three and one more, I am taking 200 .40.40.0. If you take these four blocks, is it possible for subnet for supernetting? First condition, number of blocks must be power of 2. Okay. Contiguous fashion. Okay. Second condition, contiguous. Okay, we have done it. So third condition was first address should be divisible, na? So here first address is not divisible by total number of IP addresses demanded. Total number of IP addresses demanded are 1024, but 37 is what? 100101. This is 37, and last here we have 8 zeros. So this address is multiple of 256. It is not multiple of 1024. So these four blocks cannot. Now see the reason behind it, why we are not able to give it. For example, if in this block, see, according to rules and regulations, internet router will hold this is the first address, so internet router will hold this. So you will get 200.40.37.0 in internet router, and what they will apply? Supernet mask. Supernet mask is the same only, 255.255.252.0, same only, na?
Yes, sir.
And if the same packet arrive, so I'm just doing it for the formality, 40.38.36, this is in this block only. Okay, this address is in these four blocks. So if I AND it, what I will get? I have done already. We will get 200.40.36.0, but router has stored 37, so it will say mismatch and he will not be able to forward. That's why I have written here, see this, routing not possible. I have told you na, to make routing possible.
Yes, sir.
So routing will not be possible. Router will not be able to find two. It was expecting 36.0, but we are getting 30. But router was expecting 37, but we are getting 36. Okay, so it won't be able to forward the packet. That is the biggest reason, and that is the biggest problem. That first address should be divisible by total number of IP addresses demanded.
Yes, sir.
Okay, so that's it. So this is all about supernetting. So some questions I will solve so that you get more clarity. Take the snapshot. I will jump to the next slide.
Done, sir.
So this first address divisible. Many questions have been asked. So let me say. So for example, I say an organization need 500 IP addresses. So how many IP addresses you will give? 512, because multiple of power of 2. Na? That's why 512. 500 is not a multiple of power of 2. So we will, if organization is demanding 500, I will give 512. That is for sure. And how I will give? 2 block of class C.
Yes, sir.
I will give that. Okay. And now they are saying which of the following can be starting address. So they are saying which of the following can be starting address. So A option they are giving 200.40.50.0. B option is, let me copy it out. Okay. So here I am saying 51. Here I am saying 52, 53, 54. Which of the following can be starting address? Please let me know. So how you will solve it? 500 IP addresses. That means what? 512 IP addresses will be given. So total number of addresses should be multiple of, or first address should be multiple of 512. Multiple of 512 means continuous. We want 9 zeros. So this 0 means 8 zeros for sure. This 50 is an even number. Since it is an even number, so last bit should be 0. That is for sure. So we will get 9 zeros. So this can be given. Any doubt here?
No, understanding it, sir.
Okay, very good. So 51, this is an odd number. Here we have got 8 zeros, but here 9th zero we are not getting because it is an odd number. So last bit will be 1. So it is not possible. Similarly, it is possible because even. This is not possible because of odd. This is possible because of even. So for 512 IP addresses, this last will be 0 and second last should be even. That's it.
Yes, sir.
Okay. Yes. So take the snapshot. I will jump to the next slide.
Done, sir.
Now if any organization need 1024 IP addresses, 1024 IP addresses, starting address I want, so I'm saying 200.40.36.0 B option. Let me copy that out. 36, 38, 40, 41, 60. Which is correct, which is wrong? 36. So 1024 IP addresses means continuous 10 zeros we want.
Hmm.
8 zeros from here, 2 zeros from here. 20 means multiple of 4. This number should be multiple of 4. 9 4 the 36. This is multiple. This can be given. 38 is not multiple of or not given. 40 multiple of or given. 41 not. 60 it is not multiple. 60 is multiple or not? No.
Multiple of 4, sir.
60 is multiple also. Yes. So it can be given. So I hope you have got the point, na?
Sir.
Similarly, they can give 2048. 2048 means continuous 11 zeros we want. 11 zeros means from here we want 3 zeros. 30 means multiple of 8. So whatever number is multiple of 8, you can give it. Okay, so let me say for 2048 IP addresses. This is multiple of 8? No, it is not multiple. It cannot be given. This is multiple of 8? 38? No. 40? Yes. 41? No. 60? 60? No. That's it.
Yes, sir.
Okay. So now we have done each and every type of question in subnetting also, supernetting also. Supernetting basic questions are supernet mask, and see, let me tell you that. Take the snapshot.
Done, sir.
Okay. So supernetting questions. First is supernet mask finding. Second is this first address questions, like first address multiple of total IP addresses demanded. Okay, and the 3 conditions which I have told you, these conditions have been asked many times. Same conditions. Blocks must be power of 2. Okay, these 3 conditions are very important.
Sir.
Okay, number of blocks and these blocks must be in contiguous fashion and first address and so on. Okay, yeah. So I hope you have got it. So this is all about supernetting, and previously we had done subnetting. Subnetting questions have been asked lot of time. Supernetting less time because limited questions. But in subnetting, lot of varieties there. What is subnet mask? Okay, they will give number of ones and they will say how many are shared and so on. Many questions. Okay, now. So that's it. So this is all about your class full addressing. But now we are going to start classless. So we have some time. Let me start that off. So take the snapshot. I will jump to the next slide.
Done, sir.
Okay. So next is classless addressing. First of all, we should know why we are studying this classless addressing, or basically what was the problem in classful, or why classless was developed. Okay, so question is why classless developed? Why classless developed? So directly and indirectly I want to say what are the problems? What are the problems in classful addressing? Okay, so problem number 1. Problem number 1, the very first problem was lot of IP addresses were wasted. Okay, problem number 1 was wastage. Why wastage? For example, if some organization needs say 2 power 15 IP addresses, so you will give 2 power 16 IP addresses because block size was fixed, na? Wastage because block size fixed. Block size was fixed. That means either you will give 2 power 24 IP addresses, or you will give 2 power 16 or 2 power 8. Only three choices. Are you getting it? 2 power 24 demanded, give class A. 16 demanded, give class B. 2 power 8 demanded, give class C. Okay, that was the basic scenario. And by the way, when this class full IP addressing was developed, 2 power 24 means 16 million IP addresses. And when this classful was developed, at that time in entire world there were not 16 million computers. Are you getting
Yes.
it? So why this classes concept and so on? So lot of wastage was there, lot of wastage. Okay, that was the first problem. Wastage because block size was fixed. That is limited choice, limited choice. If you have limited choice, then obviously you will have to do wastage. What was the choice? Only three choices. You give 2 power 24, 2 power 16 or 2 power 8. Okay. And second condition was, so you might think, sir, we have to prevent wastage, we have already studied subnetting and supernetting. But problem was that this subnetting and supernetting concept was not always possible. For example, if you want to do subnetting, you are one organization, then you have to bring three more organization, so that total four organization become, and now you can do this distribution kind of thing. That means directly indirectly I want to say in subnetting also it was condition that it should be given to power of two organizations only. That means block should be given to power of two organization. That means block should be given to either two organization or 4 or 8 or 16 or 32 and so on. I have not solved any question saying that you give block to 5 organization or you block to 3 organization. It is not possible. Okay, so subnetting was not always possible. Similar, supernetting was very much bad. Sorry. Supernetting was very bad in the sense you need contiguous IP addresses. So imagine a scenario, you are a small company and you need 256 IP addresses. You have got them, and now your company size has expanded, and now you want 512 IP addresses. So it's not guaranteed that you will get it or not, because it is not guaranteed that if you have got one block, then second block is free. It might be given to some other organization, so you might not be able to expand. Take your home example. You are having less money and you buy a small house, and now you have enough money. Now you are not able to buy because your neighbors are not willing to give you. So you have to shift your entire place. You have to shift your entire house to some other place. Are you getting it? That was the biggest problem. So please take some notes. You should have some idea, otherwise you will forget these things. So please write it. So next point, to prevent wastage, concept of subnetting and supernetting were invented. To prevent wastage, concept of subnetting and supernetting were invented. Next point, subnetting was not always possible. Subnetting was not always possible because number of organizations sharing a block. Subnetting was not always possible because number of organizations sharing a block must be in power of 2. Number of organizations sharing a block must be in power of 2. That is a block can be given to, that means that is a block can be given to 2, 4, 8, 16 ... organizations. Power of 2 means 2, 4, 8, 16 and so on.
Yes, sir.
Okay. And next important point was, see, actually no doubt you are doing subnetting to prevent the wastage and for cost cutting, but actually there is some security issues also. Okay, so internet router do not know about subnetting and all, so they will forward the packet to site router, and this site router will forward the packet to other organization. Now for example, you consider there are two different organizations which are competitor of each other. Now they will never do subnetting because site router will receive the packet which is common to both the organization. So if somebody hack that router, then one competitor can see the packet of other competitor, and they can see the data and so on. That will create problem. So for security reasons also, some organizations were not willing to do the subnetting. So they were willing to buy a big block, and they were wasting IP addresses just because they want higher security. That was the second reason. Write it.
Hmm.
Another reason, and for security reasons, some organizations were not willing to share their block. And for security reasons, some organizations were not willing to share their block. Okay. Yeah. For example, some person do not do carpool, because just for security reason they will say, I will not share my car with someone which I do not know. Why I share my car with some others? I am willing to pay the higher cost and all. But someone will say, no, cost is my priority, so I'm willing to share my car with other persons. So it's all about this thing.
Yes, sir.
Okay. Yeah, so subnetting was not always possible, and security reasons others were not able to for security reasons some organizations were not willing to share. Okay, similarly supernetting was also not always possible. Similarly, supernetting was also not always possible. Okay, because of three conditions. Just write in shortcut. Because of the three conditions, like contiguous fashion and so on.
Sir.
Because of three conditions. Okay, so now there was a need that we should have a classless addressing. Okay, and biggest reason was that it was developed in 1990s. Why? Because now individual users were able to connect to internet. See, when internet was developed, it was for big organizations so that they can share data. But in 1990s, concept of ISPs come into the picture, internet service provider, and single user from home, like you, like me, they were also able to connect with internet. So if you want to connect to internet, you will get a class C block. Okay, that is not good. Na? You should not get 256 IP addresses. You just want one. So why you will pay for 256? That was another big reason for developing of classless addressing. So you can write that also. Another big reason was single users were now connecting to internet. As ISPs were evolved. ISP means internet service provider. As ISPs were evolved. Okay.
Yes, sir.
Okay, so now you can write the heading classless addressing. Classless addressing. So this was the motivation, or this was the reason that why this classless was developed. So now we are going to start classless addressing. Take the snapshot. I will jump to the next slide.
Done, sir.
Okay. So what we are going to study in classless? I have told you in class full, block length was fixed. Block length was either 8 or 16 or 24. So block length 8 means this is for class C. Block length 16 means class B. Block length 24 means class A. So it means 2 power 8 IP addresses, 2 power 16 and 2 power 24. Okay, we have done this thing. It was class full. Now in classless, this block length was not fixed. Okay, block length was variable. So depending upon the need, we will give the block. Okay, so we are not saying that we have only three options: block length 8, 16 or 24. Now there are many options. So that's why I'm saying block length is variable now. Okay, so we can have block length of 8, 9, 10, 11, 12, any number, whatever we want, we can take. Obviously, maximum can be 32. Okay, so if block length 9 means 2 power 9 IP addresses in that block. Block length 10 means 2 power 10 IP addresses in that block. Block length 11 means 2 power 11 IP addresses, and so on. Okay, so this is block length, and these are the IP addresses in that block. Any problem here?
No, sir.
Okay. So now we do not have this concept of net ID and host ID. In class full we were having a concept of net ID and host ID, but in classless there is no such concept. Here we have concept of prefix and suffix. Take the snapshot, I will tell you that in the next slide.
Done, sir.
Okay, so in class full we say net ID and host ID, two parts. IP address was divided into two parts, net ID and host ID. But in classless we have concept of prefix and suffix. Prefix and suffix. So if prefix length is n, total length is what? 32-bit IP address. Now so suffix will be 32 minus n. So simple. Okay. If prefix length is prefix length is n, then suffix length is 32 minus n. Okay. Any doubt here?
No, sir.
Okay. So now I can say, so for example, they will give prefix length is say 11. So what will be the suffix length? 32 minus 11, that will be
21.
21. So directly and indirectly prefix length 11 means block length is 11. So suffix length 21 means 2 power 21 IP addresses. So if they say prefix length is 11, then how many IP addresses in that block? You will be having 21 bits for suffix, na? So 2 power 21. So you should say like this properly: 2 power 32 minus 11 IP addresses, that is 2 power 21. Okay. So and if you want another example, then just for the sake of completion I can give. For example, say prefix length is given as 10, then what will be the suffix length? 32 minus 10. 32 minus 10, that is 22. So how many IP addresses? 2 power 22 IP addresses. Okay.
Yes,
so final conclusion is, if prefix length is more, then obviously suffix length will be less. So that means number of IP addresses in that block will be less. But if prefix length is less, then suffix length will be more. That means number of IP addresses in that block will be more. Is it okay now?
Yes, sir.
Please write it. If prefix length is less, the number of IP addresses will be more. If prefix length is less, the number of IP addresses will be more, and vice versa. Vice versa means you have shortly we have written. Okay. So now they can ask some conceptual questions like, if entire internet is considered as one single block, number of IP addresses in it will be, write the question.
Yes, sir.
If entire internet is considered as one single block, if entire internet is considered as one single block, the number of IP addresses in it will be, number of IP addresses in it will be 2 power 32. Entire thing is now suffix. Now there is no prefix.
Sir.
Okay, and entire internet is considered as one single block. One means what? 2 power 0 is 1, na? That means we have reserved no bit for prefix. If no bit for prefix, everything is suffix. Suffix, everything means 32 minus 0, that is 32. So 32 bit suffix means 2 power 32 IP addresses. Okay.
Understood. Yes, yes.
And they can ask reverse question also, like if internet is having 2 power 32 blocks, if internet is having 2 power 32 blocks, then each block will have only one IP address. Okay, each block will have only one IP address. Okay, so that means now 2 power 32 blocks, na, that means 32 bit this prefix is 32. So 0 bit suffix means 2 power 0, that is only one IP address in each block. Okay. So now very important point is coming. Try to focus here. Take the snapshot. I will jump to the next slide.
Done, sir.
Okay. So now we are in classless. We are in classless. But IP address is represented like this only. Okay, so now in gate exam, how you will come to know whether this is class full or classless? Obviously, sometimes they will give that consider classless, or sometimes they will give consider class full and so on. But sometimes they will not say. How you will identify it? So for identification purpose, you will see this. If some slash is given, and after slash some number is given like 24 and all, you will say okay, this is nothing but classless. This is known as CIDR notation, classless inter-domain routing.
Yes, sir.
Classless inter-domain routing. Okay. So this 24 means prefix length. See, in class full, now please do not say this is class A. Never. If this is CIDR, that do not say this is 10, that means class A IP address and so on. No, you have to follow this only. Okay, so now let me write it. Do not say this is class A. No, never. Because you have got this slash and this here 24. Okay, so now they are specifying like this. So can you have any do you give me any hint that why they are using this type of notation, or why prefix length is explicitly specified? Because now size of prefix is not fixed. Okay, earlier this prefix was net id. Net id part was fixed, either 8 or 16 or 24. And when it is 8, directly indirectly here this range will give us that this is 8. Okay, so that means 0 to 127 or 128 to 191. You will say hey, okay, this is block length is 16 and so on. Okay, so in class full by default it was there, but now in classless it is not there because variable length blocks are there. So you have to specify what is the your block length now. Okay, so prefix length here I have specified that is 24 here. So directly indirectly this means 24, first 24 bits are for, you can say, roughly net id. If I talk about class in terms of class full, I will say first 24 bits are net id, or you will say here first 24 bits are prefix. Okay.
Yes, sir.
So this is the scenario here. So if we got this slash notation, you will immediately say this is classless. If there is no slash or nothing given, you will say class A, like this. Why class A? Because of this. Okay, why this CIDR notation was invented? Because block length was not fixed, so you have to specify it. So here we will specify it. Okay, so I hope you have got the point. So now so now we will say okay, so let me solve now few questions. Okay, so they will say, let me take the snapshot. I will jump to the next slide.
Okay, sir.
So now they will say an IP address in a block is 10, 20, 30, 40 / 24. So now immediately you will say, okay, this is CIDR. That means now no longer it is class A and so on. You will simply say it is class less. Okay, an IP address in block is given like this. So now they will say find net mask, second first address, third last address, fourth total number of addresses, and the last question will be total host. So they will ask you to find this. So now I will simply say /24. This 24 means prefix length. Prefix is just like your
Net ID,
net
sir.
id. So net mask means net id all ones. So that means 24 1 is the net mask. 24 1 means this is 81 81 81 and this will be our net mask.
Hmm.
Okay, so this 24 means 24 ones in net mask. You can say like this, 24 ones in net mask.
Yes, sir.
Okay, first address. How you will find first address? So you simply add this IP address with this net mask. You will get the first address. So 10 20 30 0. Last address. Last address. So you will not the net mask and or it with the given IP address. You will get 10.20.30.255.
Not an
Are you
answer.
able to?
Uh-huh.
Any doubt?
Not an and, not an answer. I just wrote it down.
Not the net mask and or it with the given IP address.
Okay. Or.
Last address. We have solved in previous lectures also.
I know him.
So for last address, not bitwise, not the net mask and or it with the given IP address. Okay, so should I do it or is it okay?
It's okay, sir. No problem. I'll do it.
Okay, so total number of addresses. So you will simply say 24-bit net ID or you can say prefix. So how many bits for host ID or suffix? 2 power 32 minus 32 minus 24, that is 8. So 2 power 8 IP addresses. So how you have got it? I will simply say 2 power 32 minus 24, that is 2 power 8, that is 256. Total number of host minus 2, 2 power 8 minus 2, 254.
Yes, sir.
Any doubt here?
Nice, sir.
Okay, so that's it. We will wind up the class here itself. Time is up. So in the next class, we will solve many more questions like this. Don't worry, you will be fluent in these type of question. Okay. Okay then. If okay, so let's wind up the class here itself. Okay, I think I have shut down that. So I hope nobody is having any doubt here. So we will wind up the class here itself. So tomorrow we will meet the same time, I think so, for operating system.
Yes, sir. Yes.
Okay then. Good night.
Thank you,
Bye
sir.
bye.
Yes.
Okay.